Welcome back, everyone, to our second session. We are still under the introduction to power system resilience. We want to have a short video to discuss three main slides, and then we will go to what we're going to cover in the next session. So we want to talk about the emerging paradigm, which is from preventing failure to operating through disruption. First, let's look at number one. Traditionally, we had a power system were designed to prevent failure. We always assume that we have a predictable condition and isolated event. However, today, that assumption no longer holds. Systems are exposed to continuous, multidimensional stress, from weather, short of sources of fuel, to tensions worldwide. The shift is clear now, from avoiding disruptions to operating through disruption. We no longer want to avoid, actually, we would love to avoid it, but we can no longer avoid disruptions. So that's why now we want to go and operate through disruption. This required new enablers, which include energy storage, demand flexibility, smart grid, and AI-driven control. So therefore, resilience is no longer about backup. It's about continuous, intelligent operation under uncertainty. I repeat this. Resilience is no longer about backup. It's about continuous, intelligent operation under uncertainty. And I will let you go and read all the impact. From a cost perspective, key enable for a powering the shift. We have demand flexibility. You have 10 to 20 billion dollars annual save. This is a substantial amount. AI-driven market to reach $13 billion by 2030. Let's take the data center as a case study. The data center has high energy density, zero tolerance for downtown rapid growth, and they expose limits of current resilient models. So when it comes to data centers, what do we have? First, the energy intensity is extremely high, as you can see. We are now seeing 10 to 50 kilowatt per rack compared to 3 to 5 kilowatt traditionally, with large facility reaching 20 to over 100 megawatt per site. Secondly, they operate with zero tolerance for downtime. Zero tolerance for downtime. Even a single minute of outage can cost $9,000 to $30,000 in a large scale event. This escalates to hundreds of thousands of millions of dollars. This impact, it's massive. That's why we have to work on a zero tolerance. Thirdly, the growth is unprecedented. The global data center electricity demand is projected to increase from around 460 terawatt hour to nearly 1,000 terawatt hour within a few years. What does this mean to a traditional approach? Based on the traditional approach, we have n+1, we have n to n, even to n+1 is no longer sufficient. No longer sufficient. Therefore, data center are effectively stress testing our energy system. They will put some sort of test to see how stress our system will become, exposing the limit of current resilience model and forcing us to rethink how we design and operate our power system. So we have to be very, very careful and look at these data very careful and in big concerns. So every 1 minute of downtime could cost millions of dollars, and it's not that could have a catastrophic impact, could have a lead to a cascaded impact. That these all numbers are predicted. In reality, they could go beyond what we are expecting. Power system, power system are no longer static infrastructure. They are adaptive cyber physical systems. If you look at this slide, it will cover the fundamental shift in how we think about power system. Traditionally, as we mentioned before, power systems are designed as static infrastructure, centralized, predictable, and built around known operation condition and failure. However, under today, as we mentioned in the previous slide, reality is very difficult. Power systems are becoming adaptive cyber physical system. It must become an adaptive, where energy and digital intelligence are tightly integrated. We are moving toward that are distributed and diverse in sources, bi-directional in power flow, and increasingly driven by real-time data and AI. This also reinforces a critical distinction. Resilience is not the same as reliability. That's the whole idea behind this introduction. Reliability focus on preventing failure, while resilience ensure the system can continue operating through disruptions. What's next? Next topic, we will talk about the global energy landscape and system stress. Go into deep into demand growth, energy transition pressure, infrastructure gap. I hope to see you all in the next session. Thank you for listening.